Good afternoon, ladies and gentlemen of calculus. Precalculus. We are going to, before going over these, let's be very quick for the quick review. I'm just going to review the rules of exponents. Do you remember the rules of exponents?
No.
No. No. Okay, first one here is called power of power. And power of power is going to be if we have x to the power of a and we raise that to the power of b, we're going to have x to the power of ab. Angel got it. Next one we have is called product of power. And product of power, if we have x to the power of a times x to the power of b, that's going to be equal to x to the power of a plus b. Okay? Next thing we're going to have is called quotient of power. And the quotient of power is going to be x to the power of a divided by x to the power of b is equal to x to the power of
a over b.
A minus b. Okay, quotient of power. The next one, this next one has two parts. It's called the rule of negative exponents. And the rule of negative exponents is this, that if we have x to the power of negative a, that's the same as 1 over x to the a power. And conversely, Angel, if we have x to the negative a power, that's equal to what? 1 over x to the a power.
Yeah.
Okay? Oh, hey, I need to get a different version. I was going to put it in. Thank you for catching that. If, let's write this differently. If we have 1 over x to the negative a power, that's equal to x to the a power. There we go. Thanks for catching my mistake there. Okay, finally we have the rule of zero exponents. Anybody remember this one?
Anything to the 0th power is 1.
Yeah, so Will's right about this. It's going to be x to the 0 power is equal to 1. Okay, so these are the main 5 rules of exponents that we are going to be using today. You remember these pretty well? It sounds like you remember a few of these. Would review of these things be really good right before taking the PSAT?
Yeah.
Yeah, okay, I gotta remember. Let me see. Gotta remember for next year, yeah. Sorry.
Next year's SAT.
Okay, so you need to preview for SAT. It's the same general test. Okay, oh, I forgot to do this one. This one's gonna be what? So this 5 to the negative 2 power is going to be
to 1 under 5 squared.
1 over 5 squared.
To 1 over 25.
So 1/25 is our answer to number 1. And basically, you could do that level without a calculator. This one here is going to be.
You could change it to 10 to the 3rd under 1. That goes to 1,000.
1/1000. Okay, that makes sense?
These next two are really difficult.
Oh, really?
I'm being sarcastic.
Oh, is it
I think it's
5/7?
negative
It's just one.
Is it 5/7?
I think it's negative 3.
Right, 4 to the 0 power is 1, right? So that divided by 5.
Yep.
The next, this one's going to be
1/2.
1/2. And what about number 5? How are you on this one?
So do you make the 2 and 8 and then just combine it?
Yeah, so see if, I want you to kind of see if you can struggle through this one a little bit.
I can't do it.
How you doing today, Mr. G?
Pretty well. Well, I got people in the classroom calling other people.
Well, we all know who you're talking about being the loser in question. So, hi, Angel.
No need to be attacking anybody.
Hey,
She's,
I don't
Okay.
hear it.
she was distressed because she was unfairly judged.
I was
She was-
unfairly judged because of my clothing. There's
Unfairly.
stereotypes.
What's it
For
like
the
a
people that can't see
dress
the camera, there are quotations marked around unfairly.
code? What's it like a dress code?
You wouldn't know
Unfair.
because you wear the same thing every day.
Okay, well, this is a very religious school. The school board put the
Well, they want, they want
dress
to
code
Yeah, it is, it
in
is,
here because they're
Yeah.
very
I don't care what they have on against long hair though.
religious.
Well, if they're really religious, why aren't they pro long hair?
Exactly.
Because it
yeah, it reminds me of the Johnny Paycheck song. You ever heard of that one?
No.
It's called The Outlaw's Prayer. I'll play that one. That'll be good. You'll like, did you ever heard that song, The Outlaw's Prayer?
Jesus had long hair.
Have I played it?
Did he get dressed
Tell
up?
them, tell them you're being like Jesus, Angel.
Angel.
Okay. Anyway, what we have is we don't have a common
Thingy.
base, a common base of exponent, right? But what can we do to this 8 to help out?
Math.
So when we write 8 as a base of 2,
Yeah.
What?
so 8 is 2 to the
Third.
third power.
You're just put the 11
Wait,
here.
why?
So now we can rewrite this 8, I'm going to parenthesize this as 2 to the third power and raise that to the 11th. And then in the denominator we have 2 to the 28th power. And so what is this going to be equal to? 2 to the,
Would be 14. So.
How about
14
two?
minus 28.
how about 2 to the, what do you say, Jan? 33rd power.
That's bad.
God will.
Satan, Kayla.
Okay. So that's going to be 2 to the,
Oh my
Five.
God.
rule of quotients,
What are we doing in Wiley's today?
yeah, it's -5.
it's going to be 5th power here.
I got something else.
I
So.
have second.
And then 2 to the 5th power is,
65. What?
2, 4, 8, 16, 32.
What Caleb
That's what I
said.
said.
32, okay? It's going to be 32 is our answer for this.
I already got that.
But can you see that these are really feasible without a calculator, right?
Yeah, that hurt.
Okay, next. This one here. What do you think for this one here?
Do we have to simplify both to 3?
I would, because I can't write this 27 as a base of 9, but I can write both of them as a base of 3.
3, 9, 27.
So Carmen, did you get this one?
3 to the power of 3 is 27.
So Carmen says 3 to the power of 3 is 27, right? So we can raise that to 8th, and what about this one up
Did you
here?
go 3 to the power of 2 to the power of 13?
13. And so what does this end up being here?
3 to the power of 26. 3 to the power of 3.
So it was gonna, and you have 3 to 26 divided by 3 to the 24th is 3 to the
Second.
2, which is 9.
Or -9,
-9.
Plus or minus.
plus or minus,
No?
Come on.
Oh, okay, yeah. Well, we
plus or
didn't,
minus 3.
yeah, what it is, it's not, in solving for an unknown that would be, but you're not solving for an unknown, you're plugging in.
Come on, Taylor.
So that's different. But I'm glad she has that remnant, she's thinking of that, okay? That means when it is necessary to bring that up, she'll have it. Right? So I give Kayla credit for that. Okay, this one right here, radical versus rational exponents. Do you remember, I think we talked about that a little bit. I know you know that. You have this down pretty cold, right?
Will is a radical.
No?
So this is going to be,
What?
this is going to be 5 to what power here?
So, 1.
1/5.
To half.
Yeah.
To the half.
So.
Okay, and what it is, this comes from radical exponents, rational. And we're just going to transfer here. Well, if we have the square root of 5, we know that. What if we have the cube root of 5? What's that going to be as a rational exponent?
5 to the 1/3.
5 to 1/3. Okay, I want to put something else here. What if we have 3 squared, the 5th root of 3 squared is going to be what? 3 to the
2/5.
3 to the 2/5. Okay? And then also with negative exponents, if we have 1 over
Whoa.
cube root of x, that's going to be what? X to the what?
One.
Well, we have 1/3, right?
1/3.
Yeah, negative 1/3. Okay, so radical versus rational exponents. We're going to go, that's what these exercises are going to be over, essentially, okay? So this one is going to be 10 to the,
1/3.
thank you, Angel.
Didn't answer number 7.
Didn't answer 7?
Yes, you did.
Right there.
Right here it is. 5 and 1/2. No, we were going off on a tangent of these things, and after having answered that, all right, that's fine. And this one here is going to be
E to the negative 1/2.
e to the negative 1/2. Okay, because this right here is going to be 1 over e to the 1/2, and then 1 over e to the 1/2 is e to the negative 1/2
Yep.
power. And then,
Whoa.
Mr. Drew, I need Kayla to come sign out, please.
There we go.
all right, she'll be right with you. Did you do this last one here, Kayla?
Huh?
Did you do this last one? You
Oh,
want-
yeah, I already did.
Okay, yeah, you can catch up on this other stuff tomorrow. Good work.
I'm just going on to change,
What do you mean?
to change.
All right, well, thank you.
No, we didn't.
But you just don't know.
I'm going to change. You coming back from basketball?
So you can just change into basketball?
Yeah, pretty much.
Okay, and then number 10,
Dress code now.
this is what you should get for number 10, right?
That's what I got.
Everybody's good with this?
It's not what Angel got. He needs special
What?
help.
No, I thought I got it. Yeah. So-
You got this? Okay, good. So we're gonna leave it here with these exercises
Negative 1/2.
and go on to the next set.
Probably much. Colors in the backside, so I never get.
So yeah, let me get you your next one we're gonna be working on today.
Oops. Oops.
And thank you.
Isn't that just 4 to the power 4?
My body is a
log.
Well, wouldn't that?
I made a joke.
Carmen.
Here, Rick.
Carmen,
It's,
Carmen.
yes,
my body is a temple,
yeah.
ancient and crumbling.
Oh, I said my body's a temple. Just
The
kidding.
biggest room in the world is
Same.
room for improvement.
Well, that's not what I said, my body is a
I don't-
temple.
So what is it, let's see?
Log.
So we're here in the class? Let's see.
I was 8th grade last year.
Well, I'm glad today. I made Kaylee laugh. That's good.
So I really felt that joke.
We're technically all of them, probably.
I'm hurting. My back hurts.
All right. What I need to do is talk about what a logarithm is. I'm going to show probably tomorrow. I'm probably going to show real world logarithms in the real world. But today,
Can I get a calculator out?
what well, these are without a calculator still,
Well, I can't do it.
right? So what this is, evaluate the logarithmic expression without a calculator. So what I like to do for these problems is set them equal to x and then work from there. So a logarithm is the answer to the question, this base of a logarithm, in this case 4, raised to what power is equal to 4? 4 to what power equals 4? 1. So the answer to this problem is 1, just based on that logic. But let me show you sort of the workings of what we're going to do. What I'm going to do is change this logarithmic equation into an exponential equation. And what happens is this base of the logarithm, 4, you take this x over here, so it's 4 to the power of what? And then this argument goes over to the other side. So we have 4 to the x power equals 4. So we've changed this logarithmic equation into an exponential equation. And 4 is 4 to what power? 1. And so when you have the common base here, you have x is equal to 1. So our answer to this one is 1. All right?
Mr. D.
Yes.
Carmen made a song.
Oh, you did?
Let me just sing it. Never mind.
Okay, so that's for another day maybe.
Maybe.
Okay, this one here, if I write this as x, what happens with this one here?
Okay, we turn into 6 to the x equals 1.
So 6 to the power of x is equal to 1.
Zero.
Can we rewrite 1 as 6 to the power of something?
0.
We can write this as 6 to the power of 0, so x is equal to 0. So 0 is our answer to this one. Okay. Now, this one here, can I start spinning the wheel?
Yeah.
Let's spin the wheel on this one here. And there are only 6 of us here, so we'll be able to get everybody spinning. Open.
I'm calling this in.
Okay, so let's go ahead here. We have, so there's going to be Carmen, all right.
I got x equals 4.
X equals 4, you said?
Please.
No.
I don't think that's it. I think that's close, but I don't think that's it.
And it's 5.
Why did I get 16?
That's not,
Math.
X equals 5.
Should be 5, okay? How did you do that, Carmen?
In my head.
You did it in your head? And you just got it a little off? Well, it's going to be 2 to the power of x equals 32, right? And how do you write rewrite 32 as a power of 2? That's going to be 2 to the 5th power. And so x is equal to 5. Okay? All right, I'll still give you credit, Carmen, for that. Good work. I'm going to get this one here. I'm going to spin the wheel on this baby right here. It's going to be Will. Okay.
that X equals 4.
So Will says if you set this x should be equal to 4, he says.
Yep.
Okay. How did you do that one?
I set it up 3 to the power of X equals 81. 81 is 3 to the power of 4.
Okay,
So 3 to the X equals 3 to the power of 4, X equals 4.
So, as a good student that he is, who can do problems in his head a lot, he still decided to listen to the teacher. Right? And the teacher told him this: 3 to the power of x equals 81. And 81 can be rewritten as 3 to the power of 4. And there he has it. Okay? All right. Next. Does that look pretty nasty, or do you want me to call it some? You want me to do that, or do you want me to call somebody to do it? You did it?
Yeah.
Anybody else do it besides Will?
No.
Adam, did you do this one?
You're not supposed to be using a calculator.
Okay. What did you get, Will, for this one?
I got X equals 1.5.
That's not what I got.
Okay.
Is it ridiculous?
I think it's going to be,
Negative 1.5. No?
I think it's going to be 2/3 actually. But let's go ahead and work it out. Okay, what we have, if that's equal to x, then we have 5 to the power of x equals cube root of 25, right?
Yep.
And cube root of 25 can be written as
25 to the 1/3.
5 squared to the cube root, right?
Yep.
So that's going to be 5 to the 2/3. So that's where 2/3 comes from. You see that? Nope, you don't see it?
No.
Okay.
Adam, you got this?
Maybe.
Maybe. What about you, Jane? You follow what's going on here?
I think so.
She says she thinks so, to some degree. Carmen, you see what's going on? Kaylee, you okay on this one? Looks like you're a little bit, looks like the blood sugar is giving you some trouble right now.
Why is it
Okay.
Because this is, you can rewrite this 25 as 5 squared. And so, but this is to the power of 1/3. So what you really have is you have 5 squared to the power of 1/3. And then using power of power, 2 times 1/3 is 5 to the 2/3. Okay? What I'll do is, I'll go ahead and choose somebody for this one. We got, yeah, it could be Adam Baum, could be Shana, could be Kaylee, it's gonna be Kaylee. Okay, Kaylee, what do we got here? I'm sort of helped in that I remember the answers from 5th period.
6 times 6
You got this one? Do you have it? Let me see what you got.
I think I
See if
have
they're
it.
good enough. Yeah, see what you got.
Plus,
See that? Okay. All right. The answer to this one here is -2/5. Okay, who got that? I know Will got that. Did you get that? You saw it, Angel? Adam, do you see that? Carmen, you got that now? You know why it's negative, Carmen? Because you're down in the denominator. What about you, Jane? Did you get this one? Okay, did you get this one? Yeah, this one good. So if we rewrite this as 6 to the power of x is equal to 1 over 5th root of, and I'm just going to rewrite 36 as 6 to the power of 2. And then in the denominator, this is going to be 1 over 6 to the 2/5, which is the same as 6 to the -2/5. So x is equal to -2/5, which is our answer for this one. Okay? Give me credit for that. Let's go on to, actually, I'll just leave that up there. Okay. This one here, do they look different here starting in number 7?
Does log just mean 1 or what?
Yeah, let me show you what this, whenever you see log like this, that's a convention for log base 10. So what we're really looking at here is log base 10 of 10 to the 3rd power.
So it's just log to the 3rd power?
So the answer is 10 to what power equals 10 to the 3rd power?
3.
3, right? Because 3, and then if we use our formula we did, 10 to the x equals 10 to the 3rd power, x is equal to 3. Okay? Is that pretty simple?
Yep. Yeah.
Okay, want to spin the wheel again on this one? Ready to spin on this one? We have Kayla is missing here. Jane is going to get this one. Jane, what do we get for this one?
I got x equals 4.
X is equal to 4 is what Jana got. Anybody else have, did you get the same thing for that? So base 10 equals x, and so 10 to the power of x equals 10,000. And 10,000 can be rewritten as 10 to the power of 4. or yeah. 10 to the power of x equals 10 to the power of 4, so x is equal to 4. All right?
I'll do the next one if Evan doesn't want to do it. Just gonna,
I owe a bunch of people stickers here so far. Anyway, so what did,
I got five.
so
I got
5,
Yeah.
so 100,000 is, so
It's just
10 to the power of 5 equals 100,000. So 5 is our answer for that.
I got that too.
Okay, I owe people a bunch of stickers, okay? And this one is going to be,
X equals -4.
x is equal to -4.
Yep.
Okay, same thing. If we have 10 to the power of x equals 10 to the power of -4, so that's all there is to that one.
Yep.
And then this one is going to be,
X equals 1/3, because you can change the cube root of 10 to 10 to the 1/3.
so you have 10 to the power of x equals cube root of 10,
Right?
which equals 10 to the 1/3 power.
Yep.
Okay, and
X is equal to -2/3.
Yep.
x is equal to -2/3. So because we have 10 to the power of x equals 1 to the power of 1 over the square root of 10 to the 3rd power,
Yep.
and that's going to be equal to 1 over 10 to the 2/3, and that's going to be equal to 10 to the -2/3, and so -2/3 is the answer there.
Yep.
What I want to do, I think today, is just sort of leave it right. This gives us a clean break going into tomorrow, and then we're pretty much on line with the other classes. So thank you for that.